This is Algebra 1, Lesson 33, Practice. It's involving prime factors and missing number word problems with unequal quantities. So here's one of our missing number word problems. Find a number that we'll call n such that 8 times the number. So normally at the end of the problem they'll say find the number, but here at the beginning they said it. So find a number such that 8 times the number is 36 greater than the opposite of the number. All right, we've got a little simplification we can do here. That could just be 36 minus n to make it a little more simple. And then we've got variables on both sides. So I'm going to add n to both sides. You could have subtracted 8n from both sides. But I think this is a little faster. 8n plus 1n would give me 9n's equals 36. Now I'm going to isolate the variable by dividing both sides by 9. And n is equal to 4. And they ask us to check that. So find a number such that 4 times the number, okay, so not 4 times the number, it says 8. Such that 8 times the number, and we think the number is 4, is 36 greater than the opposite of the number. So 4 times 8 times 4 is 32, and 36 plus a negative 4 is 32. So it checks out. If the sum of a number and 6, this is problem B. If the sum of a number, so here's our number. If the sum of a number and 6, sum is answer to an addition problem. If the sum of a number and 6 is multiplied, okay, now that sum is multiplied by 2, the result is 10 greater than the number. Find the number and check your answer. We're going to need to distribute here because we can't do n plus 6. So we get 2n plus 12 is equal to 10 plus n. We can't really combine any like terms on either side, and we have variables on both sides. Let's get rid of one of those. We could subtract 2n from both sides or subtract n from both sides. I'm going to go with n. 2n's minus 1n would just give us 1n, and that's plus 12 equals 10. Now I'm going to subtract 12 from both sides, getting rid of the constant that's with the variable. And n is equal to 10 minus 12, which was negative 2. Now let's check that. If the sum of a number and 6, all right, here's our number, and its sum with 6, is multiplied by 2, the result is 10 greater than the number. So let's add this together. That's going to be 4. We're going to double it, and that's going to be 8. And 10 plus a negative 2 is a positive 8. So it works. Last two practice problems. Write the following numbers as products of prime factors. I would go factor tree on this. And I would notice that 108, when you add up its digits, 1 plus 0 plus 8 is 9. And 3 is a factor of 9. So I would say 3 is going to go into that number. So we need to find out 3 times what. So let's do 108 divided by 3. 3 times 3 is 9. And it'll go into 18 6 times. So we see that this number is going to be 36. Now, 3 is prime. It only has 2 factors, so we can circle it. 36 is composite. What do we want to do? I'm thinking, how about 4 times 9? You could have done 2 times 18. 3 times what would that be? 12? Yeah. Sorry, memory lapse for a second there. There's lots of things you could do. But neither of those is prime, so let's break those down. So the prime factorization for 108, I'm going to put them in order. That's 2 times 2 times 3 times 3 times 3. And you can multiply that back out and check it to see if you get the right answer. And you do. All right, for 400. I see that it ends in 0. So I know 10 will go into it. It actually ends in 2 zeros, so I know 100 would go into it. So I'm going to go 4 times 100. Neither of those is prime, but I can break 4 down to 2 times 2. I can break 100 down, I think, of 4 quarters. So 4 25s. Neither of those is prime. That's another 2 times 2. And this is 5 times 5. So see, that the first breaking down, like right here, that may be a little harder, or where we went here, but the further you go, the easier it gets. So I would write my prime factorization for this as 2 times 2 times 2 times 2, and then times 5 times 5. And there's your prime factorization.